What's up, dudes? So I'm back here with my main man, Allan, and we decided it would be fun to compare how you would write a function in Clojure to how you would write the same thing in JavaScript. Allan's come up with the idea of making a function like converting a map into a key value store, something like that. Do you want to describe what you want to write?
It won't quite be like a key value store, but it's the same principle. So we've got an array of maps, and we want to look up something from that array. So instead of looping through the array each time and checking what's in each map, each time we want to look something up, we loop once and we create a lookup table. And then each time we do a lookup, we don't have to loop. We just do a quick lookup. So that'll just be like grabbing a key out of a map.
Okay, yeah. Save on that performance.
Yeah.
For just an FYI, we are already 20 minutes in and we decided to redo.
Yeah, just for fun, not technical reasons.
Yeah.
So the first thing I'm going to do is an HTTP request. So I've got this library here. It's called CLJ HTTP. We chose it because it seems to work, which is cool.
So working is one of the things you really want to look out for in a library.
It is an important attribute. Okay, so
yeah. We'll
just grab this. This is the name of the dependency and the version. And then we put that in our project file, which I've already done. Very nice. So we can see it here. So then when we start our REPL, yeah?
That's basically just an array of different packages. This is, like we discussed before, this is very similar to a package.json file. And these are the dependencies that your project needs to run.
Yeah. Simple as that. Okay, so my REPL is started. So we'll switch to the REPL buffer.
So small.
It is small, but now it's bigger.
Nice.
Okay, so we need to require this namespace. So we'll just copy this out of the documentation. We all know all good programmers mostly paste, copy paste. So
yeah.
That's what we're doing.
Oh, okay. Brilliant.
Okay,
so
cool.
So just what you're doing here is basically importing it.
Yeah, so what I'm saying is make sure that these classes are loaded. Classes as in Java classes, because of course Clojure libraries are compiled to Java. So make sure these are loaded and then alias them as whatever you put after as. Okay, so in this instance it's client. So client will refer to this namespace. It's just an alias. It's just a little shortcut.
Okay.
So you can see here in the documentation, I copied this, so they've aliased it the same way. So now get is a function inside that namespace, and it's just being called here. So here's the API we want to call, the little test API at request, whatever that's called. So we'll just reference the namespace, the function get. Oh, okay, we probably need to wrap that in quotes. Okay, so now we're going to call get, we're going to pass in the string, which is the URL. So let's run it and see what happens. Okay, so there's the response, but that's not too easy to read. So I'm just going to print it. Okay, so here's our response from the server.
Oh, cool.
So we can see this is a map with a whole bunch of stuff. We're not interested in anything but the body. Okay, so that's cool. Okay, so let's think. Well, we should probably wrap this in a function, and then we want to extract the body and we want to JSON decode it, because it's JSON and it's just it's a string. It's a string of JSON, and that's not very useful in Clojure because we want Clojure data types. So let's just create a function. We'll call it get users. It will take in nothing. So then we'll create a let block. So we're interested in the body, and the body is a key in the response map. Let's just call it response. And we'll just steal this. we'll put it right here. Okay, we got our response. Cool. So now we want to do a JSON encode. We want to encode the string into JSON. I haven't memorized that.
But don't you need to decode it?
Sorry, decode it. Yes, my mistake. So we'll grab this Clojure data JSON library. Another dependency.
Okay. This one works, eh?
Unlikely. No, I'm pretty. Look, I use it all the time. So I mean, I use that other thing all the time too. But I use this all the time, and it works well. So I've added the dependency, and I'm starting the REPL up again. Oops, I didn't save the file. Okay. Okay, save the file.
Saved.
Opening the REPL. Okay, let's just have a look at how this actually works. Okay, so JSON read string takes a string, outputs a map. Okay, that's what we want. We want this exact thing.
So a map in Clojure is very similar to an object in JavaScript. Same, you'd use them in the same situations.
Yeah, so it's or an associative array in PHP. It's just something that has keys that are not numerical or can be numerical. But
Okay.
the key can be anything. Okay, so we don't want that. We want the body from our response. So we'll take the body key out of our response and we'll pass it into JSON read string. I've forgotten to acquire it into my namespace. Let's do that quickly.
Do you know what that, you also have that keyword, that key FN?
Yeah. This key FN keyword, what that does is it says when you're busy creating a map and you have keys in the map, apply whatever function to those keys. So, well, actually what we can do is I can just comment this and then we can see what happens without it and then with it. So I'll just comment that out quick. Let's just tidy this up a bit. Evaluate the function. Okay, let's call this function. Okay, there's our body. Maybe we should print that again. Of course, I could just require the clojure.pprint namespace, but I just have a habit of not doing that. Okay, let's get our REPL buffer again and zoom in. Okay, so here's our JSON decoded map. So you can see the keys in this map are strings. So in Clojure, we normally have our keys as keywords instead of strings. So this is going to be hard to use in Clojure. So we want to convert these to keywords. So that's where this comes in.
Okay.
That just says each time you come across a keyword in a map, apply this function. And the keyword function takes a string and outputs a keyword. So if we remove these, if we uncomment this, and then we run again, we'll see that we now have keywords here.
Okay.
Yeah.
Okay. So, yeah, like I see you're using the keyword to get the data out. So like using the body keyword to get the data out of the response, to get the body out of the response.
Yeah.
So you can do the same thing with...
Yes. So in Clojure we have this cool property, or rather, I guess it's not a property, but keywords are functions. They are also functions. So I'm calling the body keyword as a function and I'm passing it a map. And what's happening then is we end up looking inside the map for that keyword. It's kind of strange. It's not something I've come across in other languages, but you get used to it. You could also just go, you could use the get function, and then go body, and that will do the same thing. That'll just say, get body out of this map.
Okay, so that's what you would do if you kept the strings in place. You would use the string body.
Yeah.
Because you can't use string as a function.
That's correct. Yeah.
Like you can. Yeah.
You can actually swap these around too. So you can. Whoops. So the map itself can also be called as a function and pass the key. So.
Oh, okay.
Yeah, it's just lots of ways of doing it. This kind of thing can be useful because you can do the same thing with sets. So, but we won't talk about that now. Anyway, okay, cool. So I've got the body now, and it's a map, and I can deal with it. So we want to look up someone by an email address, or maybe ID, because ID is just an integer and easier to type. And also, it's probably a bit more common to do a lookup by ID.
Yeah. Yeah.
Okay, so we've got a map called data inside the body. So the first thing we'll want to do is grab that. Then we'll have this array, and then we'll create a lookup table from the array. So what I'll do is I'll pull this into the let binding, and I will give it a name, body.
Okay, so you've bound the result of the body to the variable body.
Yeah.
It's not variables, eh? It's
a binding. So now I got body. So now, okay, I want to pull out data, and then I want to create my index, my lookup table. An interesting thing about Clojure, because we have this REPL development, there's two ways you can do this. So you can either write the code inside this get users function and keep executing it, or you can just write, create some test data and write the function and just leverage the REPL.
Okay.
So what I do is I normally do the latter. So I define some test data, and that would just be an array with a map, and it'll be like ID 1. And then, so I generally try and use the smallest amount of data I can. So we've got an array with 2 maps. So in order to create our lookup table, this is the bare minimum amount of data we need. So I'll execute that. And now we can try the different approaches. So we can do map. Okay, let's rather do the reduce. Yeah. Okay, so we'll do a reduce.
Okay, just to let everyone know, so you get a lambda sign for when you create an anonymous function with your. So that's just fn, but it looks.
Yeah. So anonymous function in Clojure is fn. So I just type f, and then as soon as I type in, the editor just replaces it with that cool character. It does that with a whole bunch of things. So there you go. All I did was type in. Yeah.
That's fun.
Okay, so let me just add a default. Okay, so with our reduce, I always name the arguments to the reduce function like this. Ac stands for accumulator, and it is the current iteration. So
okay.
Yeah. Okay, so the first iteration, or the first value it will be this first map. Okay. So we want to grab ID out of the map, and we want to create a new map that is indexed by ID, right?
Yeah.
So there's 2 ways I can grab ID, but we'll do it the longer way because we probably don't want to do destructuring now.
Yeah.
So I'll create a new binding ID. I'll grab ID out of the current iteration, and then I'll associate it into into our output, our index table, which is a new map. And the key will be the ID, and the value will be the current iteration, which is the map. Right?
Okay. Yeah. So you're creating a reference to the ID and associating it with the map which it's in also.
Yeah. So let's run this. Okay, so there you can see that's the output we're looking for, right? So we've got a map, the key is 1, the value is the map with ID 1, and the same for 2. So that's cool. That's what we want. I can show the destructuring real quick just because.
No, I think it's a good idea to show it.
Yeah,
because it's also something I can do in JavaScript as well.
And it'll be really simple. So instead of pulling it out in a let, we can just do this. We can do that. Oh, sorry, I've done that wrong. This is supposed to be a map. So we're pulling the ID key out of the current iteration, which is the map, and then we're aliasing it as it again. So now we can just push this out of the let. Then so now the let isn't required anymore, obviously.
Yeah.
We can kill the let. Okay, so now this will do the same thing. It's just a little bit neater.
Okay, cool. Yeah, and that's so passing the whole object in as the second argument, like a normal reduce, and then destructuring the ID out of it, and renaming the renaming it is quite cool. Yeah.
So now because I created some test data, and then I wrote a function here, and I verified that it does what I want it to do. I can take this function and I can put it up here in the function I'm actually working on. We can get rid of this stuff now because we don't need it anymore. So now, of course, T is gone because I deleted it. Instead of that, we want data which is inside body. So we'll just grab that out quick. Data, pull it out of the body map, clean it up a bit. So now let's see what we get. It's no top. I can't remember how to clear this. So what I'm going to do is the
classic. Okay.
Is the press enter hack. Okay, and of course it prints it above. Well, anyway, let's look from the bottom because you can see it's done what we wanted to. So there's the key, there's the map.
Now you could show like using it. So you would take if you wanted say you wanted the user with ID of 7.
Yeah, so I'll use the get function on the users, and then I know it's a string, so I'll say the key must be 7. So get a user with the key 7, or rather get something out of this map that has the key 7. So we get this is a map, it's definitely a map, and we want 7, please. Okay, yeah.
Oh, you know what? Maybe 7 is not a string, but an integer.
Oh my god, my battery's fooked. Yeah, you may be right. That would make a lot of sense because there ain't no brackets around those.
Ain't no brackets.
I mean, quotes.
Quotes.
There we go.
Boom.
So quick and easy.
Score, dude.
What is that other way though? What was it? It's like really simple. Once you know it. So that takes a function, takes multiple functions. It calls those functions on each thing.
What is Juxt?
It's a function that juxtaposes many functions.
Oh, okay. So I thought you were joking.
So ID and identity, and then Yeah, and then we'll thread it. So I'm skipping my step with simpler data, like a silly person. And then we'll convert it back to a map because that will return a bunch of vectors. Oh, I know what I'm doing.
Oh, you got to double thread it. Wrong.
Yeah, I'm sending it in as the first argument when it should be the last. Okay, there we go. See, correct output.
Okay. I understand that entirely, so no stress.
So what it does is pretty simple. Juxt it returns a function that will apply each function you give it to the value it gets. So,
Okay.
let's say you pass it. It gets passed one key value from the map, right? Gets passed to the function that Juxt returns. And then that function passes that key value pair to ID and to identity at the same time. And then the results of those get returned in a vector.
Juxt returns a vector.
Juxt returns a function, and the function it returns will apply the value passed to it to both of these functions.
Okay, I get it. I get that now.
Yeah.
Okay, so first, we get the body, you get the IDs from the body, and then it runs identity.
Yeah, so identity just returns what you give it. When map is iterating, Juxt will get the first map in the vector you're trying to turn into a lookup table. So it will get a map, and then ID will be called on that map, which will return like the ID 7, and identity will also be called on that map, which will return the map itself. And then those two values will be put in an array or a vector and returned. So if I turn off into, which will stop it being converted into the final map, you'll see what Juxt is returning.
Okay, I get that. So you get two values in the array, one with the ID, one with the data of where the ID comes from. And then you just put that as a key value into map. Into takes a key and a value.
I don't understand. But look, this is what it does. You can see. So the function that Juxt returns, when called, returns this. The 7 and then the map.
Yeah.
In a vector, yeah. And then into converts the array or the list of vectors into a map, back into a map.
So it will use the first value as the key and the second value as the value of the key.
Yeah.
Okay, that's cool.
Yeah, so that like this, the reduce is easier to understand if you know what reduce does.
Yeah.
Because you only need to know what reduce does and then read the anonymous function, and then you'll know how it's working. But if you know like what map, Juxt, identity does, and into, this is easier to just look at quickly.
What's up, guys? So things went a bit wayward last time. We're back in it. I just wanted to write the function that Allan wrote in Clojure. I'm going to do the same thing using JavaScript, but I'm using Deno, which uses TypeScript, but I'm going to ignore the TypeScript-y stuff and just do it in like basic JavaScript. So here's the function that Allan wrote, which you should probably know because you saw it like 10 seconds ago. Okay, so I'm actually just going to, I'm going to keep this here because I'm going to try and write it like as word for word, as code for code as I can. What did you say last time about, how did you describe it? Porting. I'm going to port the function.
Yeah, you're going to port
I'm going to port this function.
Yeah.
Okay, cool. So the first thing you did was you defined a function called getUsers. So I'm going to do the same. I'm going to say const getUsers, and I'm going to make that an empty function. Cool. then you got the response of that call to that API. So I'm going to say const response is equal to fetch, and then that address.
Does fetch only GET requests, or what? Or does it? Just?
It's like any HTTP request, so you can post with it. It's weird. It's weird when you have when you do a post, but it's actually like the function's name is fetch. You can pass you pass it through as like an option.
Okay.
And then it'll change the type. Yeah.
Fetch post.
Okay, cool. So I'm gonna extend this a bit. So okay, so now we're fetching that. So in order for us to await it, make this an async function, and we can await the response. And then, okay, so then you're getting like the body. So I think I'm just going to return the JSON of this. So I'm going to say data response.json, and I'm going to log what we get out of the data. So that will convert the response to like a JSON response. And I think this is also async, so I'll wait this. And I'm going to log data here and call get users. And because I'm using Deno, it's top level async, so I can actually await this here. So to run this, I'm going to say Deno script .ts. Deno run script.ts. Okay, yeah. So this is like a thing with Deno. You have to, for it to like interact with the web, you actually have to say it. Like you have to allow it. Allow net script. So this, yeah, okay. So data, I'm getting the whole payload, and I need.
You got data in your data.
Yeah. So you were getting in your request. You were getting the. You're reading. So you were getting the. So I didn't actually have the body. The body.
Yeah, because I get back a map of the request, which is kind of like a ring style map. A ring is a Clojure library. So in Clojure, you'll get back the whole request, which will give you some metadata about the request and not just the actual response.
Okay, cool. So I don't get that. But now I still need to grab data from this body. So, users is equal to data.data. This is what I have been doing recently is actually wrapping these in.
Oh yeah.
So you can await this twice and then call that response. I think this makes more sense. And then you'll say users is equal to response.data.
The second or the third line makes more sense, but the second line makes less sense.
So awaiting this, oh wait, because you have to actually await this .json.
Oh yeah.
And then we can log our users. That should work. I'm just going to extend this, and then when I need to select your code, I'll bring it on screen. And then let me just clear this and run it again. Cool, we get the users. Okay. Okay, so this is the users, that's that. Then I'm so worried about like it not being visible on the screen. Okay, then you run map. Okay, so I'm going to do this one. So you just run a reduce on users and associate the ID of the user with the actual user. That's easy enough. So then I'm going to run through users, run reduce on users. And reduce takes that function with the accumulator and the value, which is, I'm going to say user, and then the starting value. And then I'm just going to return, then accumulator, then it's the user ID, is equal to the user, and then return the accumulator. And if I return this, I should get that map that you had. Just let me double check it. That's right, eh?
You've got my code as the return.
This actually won't run because it's TypeScript, so I have to specify the type. It's not, so you can just write any. It's not super strict. And then run this. Oh, okay. Then we need to log the output. So okay, let's log get users. Cool, so we have it, 7,
Nice.
8, 11. So now if we can actually make like a users map. And then we can log like users map. And then the user with the ID of 7 and run that.
It's like magic.
It's magic, dude. I want to try and put these like functions side by side. I know you're an avid JavaScript fan.
I do love JavaScript.
In this case, I actually I think they translate pretty well into each other. This kind of thing I prefer. So we're here. So like it's nice that reduce is like an external function. It's not a function that you're calling. Like it's not like the array has that function. And I always find that annoying with object types having specific functions. Like you can't loop over an object in JavaScript, and then you're like, why?
Yeah, come on.
Like you have to like it's like there's a workaround for it. But I mean it should be native. And here I feel like you basically could use reduce on body, I'm assuming?
Yeah,
Yeah.
I could. Yeah, in Clojure you don't really, well the common functions you use like map, reduce, filter, you know, all of those kinds of functions. You don't really think about what you're actually giving to them. You know, I mean you can give them a string if you want. And it'll map, well, loop through the string. So you just kind of chuck whatever you want in there and
It'll try its best to like do its thing.
Yeah,
yeah.
it will, yeah.
Which I think is really cool.
Yeah, I'm not a big fan of the whole like extending, like in JavaScript where you take the array, what they call it, like prototype, and then you add functions to it. It would be cool to maybe find something that is very Clojure-y, you know, like it's hard to do in JavaScript but it's easy in Clojure.
Yes, I would love to do something
explore
like
the
that.
differences.
Yeah, because this
maybe one day I'll think of that.
Well, this is like very one-to-one, and that's like why it's cool we can do this. But I'd like you to write something that would be hard to do. Yeah.
Well, it just shows you that things like reduce, map, filter, they're really useful constructs that translate well between many, many languages.
Yeah.
So it's nice, you know, that you can learn it in one language and use it in another. It's very cool.
Yeah. Yeah, agreed. Language-specific syntax is a bit annoying sometimes.
Yeah. Like a weight.
I could use then. Okay. And then like, whatever. Okay. If you guys like this stuff and you want more Clojure videos, you'll get them regardless. But just like and stuff. Cool. No, this was a fun one. Thanks, dude.
Cool, sweet, man.
Cheers.
Thanks.
Bye.
Hold me close till I get up. Time is barely on our side.